Hi, my name is Dr. Allison Ames Boykin. I'm an assistant professor in the Educational Statistics and Research Methods program. Many of you attended either an in-person or online workshop for SPSS given by one of our graduate assistants, G. Lee. There were questions that came up both in the in-person and online workshops, so we thought we'd give you a different video that would address both sets of questions in one, so that if you attended the online workshop, you wouldn't miss out on what was discussed during the in-person workshop. Today's workshop objectives are to understand the basics of SPSS. We'll show you how to read in data into SPSS, how to save data in SPSS. We'll show you some simple summary statistics like frequencies and crosstabs, and then we'll also show you how to visualize your data. So what is SPSS? SPSS is a statistical software suite used to perform statistical operations. The SPSS abbreviation comes from Statistical Package for Social Sciences. The software has a robust set of features. It's user-friendly, so that means that there are point-and-click menus and you don't have to write your own syntax. You can perform a wide range of statistical analyses, and it's quick to manipulate and easy to use without any coding skills. It also reduces your data preparation time. And you're able to integrate SPSS with some other statistical tools such as R and Python. SPSS, the default interface, is the data editor. So when you open up SPSS, what you'll see is the data view and the variable view. Let me take you to that. So when you first open up SPSS, it looks just like this, where you have a data view and you can switch to the variable view. Now the data view is if we had a data set open where your data would show up. And the variable view contains attributes about the data. So the data view is first visible when you open SPSS. It's a spreadsheet-like system for entering, defining, editing, and displaying data. Each row represents an observation or individual, and each column represents a different variable. The extension of the saved SPSS dataset is SAV. So if we were to create a dataset and save it, it would have the extension .sav on the end. I'll show you what that looks like in the folder. So here we can see that I have a dataset called grit.sav, and that's what we mean by extension. After dot, that tells me that this is an SPSS dataset. And in my Windows Explorer, it shows me that the type is an SPSS statistics data document. Now the variable view gives us information about how variables are coded, the measurement scale, and if there's any missing data. And you can type in other information if you'd like to. The name, and this is again in variable view, is the name of the variable in your data set. One key thing to note is that spaces are not allowed. The first character must be a letter, but you can have numbers as long as they don't begin the variable name. Variable names have to be unique, so you can't name a variable item and then another variable also named item. You can use the underscore to separate two or more words. For instance, dog underscore owner, if you wanted to create a variable to represent dog owner. Now the variable name can be a maximum of 64 characters. The type allows you to specify the type of variable that you have. So in type, you'll have options such as numeric, comma, scientific notation. String variables are character variables. So a numeric variable contains only numbers and is suitable for numeric calculations such as addition and subtraction. In contrast, a string variable contains letters, numbers, and other characters. You can't do computations on string variables, even if they contain only numbers. So it's important to note how SPSS is thinking about your variable, whether it's seeing it as numeric or whether it's seeing it as string. Now width, this is for string variables. It refers to how many characters a value can hold. For numeric variables, width refers to how many digits there are. Decimals of a variable tells us how many decimal places SPSS will display. Label can be a longer representation of the variable, so it can contain more detail about what the variable represents. The label could be one word, or it could be an entire title describing the variable. The maximum characters allowed here is 256, and the label, in contrast to the name, can contain spaces. Values tells us if they're string variables. It tells us what is used to define each number or letter of the alphabet. And this is important because your charts, figures, and analysis are printed to include the values. And we'll show you examples of how to update the values. Missing tells SPSS how to treat certain values. So if you have missing values in your data set, you need to tell SPSS what represents a missing value. If there are no missing observations, you just select no missing values. But you might want SPSS to treat values such as -99 or a period to be a missing value. Columns, align, measure, and roll. These are less often used by researchers, but columns specify the width of each column. Align is an alignment property, whether it should be left justified, right justified, or centered. Measure indicates the level of measurement, and there are 3 levels in SPSS: scale, ordinal, and nominal. SPSS does not differentiate between interval and ratio. They're simply lumped together as scale. And the role that a variable will play in your analysis, whether it's the independent, dependent, or both, is included in the role column. So how do we get a data set into SAS or into SPSS? There are 2 ways. One of them is if you have a data set that's an SAV file, you can just double click on that data set and it will open by default in SPSS. The way that we're going to show you is opening SPSS first, and then File, Open, and then finally Data. And I'll demonstrate that for you. So we're going to start in the top left-hand corner with File, and then Open, and then Data. Sorry, my file importer left the screen. So let me see if I can get this going for us. So File, Open, Data, my apologies. And then I'm going to open from the Workshop 2021 folder this grit.sav data set. I'm going to click on it and then Open. So again, to get this data set open, I went to File, Open, Data. And then we see all of the variables in our data set. Item 1 through item 12, we see EDU, gender, age, urban, pre-test, mid-test, and post-test. So if we go over to variable view, we can learn a little bit more about our data set. Now, item 1 through item 12, they don't have any labels, but education through the end tells us that EDU represents educational attainment. And if I click on that value box, what I see is that 0 is for a professional degree, 1 is less than high school, 2 is high school, 3 is university, and so on. I can do the same thing with gender. Now, SPSS is telling me that gender is a string variable. When I click on the values, I see that F represents female and M represents male. Age is numeric, so there are no values for it. But urban, even though it's numeric, 1 represents rural, 2 represents suburban, and 3 represents urban. We can see that SPSS is telling me that educational attainment is ordinal. And that does make sense to us, that gender and pretest are nominal, that there's no order. Now I might want to change that, but when we look at, for instance, urban, rural, suburban, urban, I might not be able to rank those. So nominal makes sense to us. When I'm looking at education, SPSS has ordered them 1, 2, 3, and 4, but a professional degree doesn't necessarily rank lower than less than high school. So rather than ordinal, I'm going to change that measure to be a nominal variable. So what that's telling SPSS is that the order of these categories doesn't matter. Now, less than high school through graduate degree does, because that indicates more years of schooling as you increase. However, professional degree, something like a law degree, has just as much schooling as a graduate degree. So putting it 0 doesn't mean that it's the lowest in terms of educational attainment. So that's why we changed it to nominal, because a nominal variable, the order does not matter. Now, throughout this workshop, there are learning checks, and I encourage each of you to try to import these different files and try out the learning checks on your own. For each learning check, immediately following are examples of how to do the learning check correctly, or the solution to the learning check. I'll show you this first learning check because it's asking us to import an XLSX, or an Excel file, and that's a little bit different. I'm going to go to File, Open, Data, just like I did before, but instead of it being an SPSS file, I'm going to choose Excel. And then within that folder, I'll see all of the different Excel files that I have. And I would just click on the Excel file that I want to open and then open it. What you'll see is that I get a nice preview of what that file looks like. I can tell SPSS to read the variable names from the first row or not. And then I can hit OK. And with just a little bit of time, it will import that data set for me. So we'll see all of the different solutions for how to do that in the PowerPoint. So you might also want to enter your own data set into SPSS. It might be easiest to first define your variables in the variable view window, then enter your data in the data view window. So let's see how to do that in SPSS. So in order to do that, I'm going to get a new data set. I'm going to go to my variable view, and then I can begin typing the variable names that I have. I have name, age, and gender. And for brevity, I'll just do a few of those. Now, I want name not to be numeric, but to be string. Age is numeric, but the way that I'm going to define gender, I'm going to use M, F, and O, and I want that to be a string variable. So then when I switch to my data view, I have my 3 variables. So Fred is 34, and when asked about his gender, Fred provided M for male. We're going to use Sal. Sal is 27, and when asked about Sal's gender, they provided an O for other, or chose not to reply. And then we'll do Sally, who is 67. Sally selected female when asked, and so on. So we can simply type in our data if we want to. Now, of course, this is going to be cumbersome if you have a large data set. So I would only do this if you have a very small data set. Otherwise, I would try to import your data from an external file. Once you have typed in your data or manipulated your data to work with it, you're going to want to save it as an SPSS dataset or another external file type, because you don't want to have to type this data in by hand each time you use it. So you would go to File, Save As, and then you can choose to name it. I'll call this Workshop Demo, and then just hit Save. And now we can see that SPSS has changed the name to Workshop Demo, and in my Workshop folder, I now have this Workshop Demo dataset. So let's talk about some basic analysis that you can perform in SPSS. We're going to start off with frequencies or crosstabs commands for counts. Both of these commands are used to obtain information on the number of cases that have a specific characteristic. The frequency command is used to obtain counts on a single variable's values. For example, we can get counts for each category of gender. Now, the crosstab command obtains counts on more than one variable's values. So for example, we could get a two-way contingency table of educational attainment by gender. And I'll demonstrate both of those. In order to get frequencies, we're going to start with the Analyze menu. So when you go back to SPSS, you'll notice that there are different menus across the top. We're going to start with the Analyze menu, and then Descriptive Statistics, and then Frequencies. Descriptive Statistics, you'll see, contains things like frequencies, simple descriptive statistics where you could compute means and standard deviations, crosstabs, and some other things. So we go to Analyze, Descriptive Statistics, and then Frequencies. So the frequency window pops up, and the variable that we're going to first look at, let's say, is gender. Now I could move more than one variable over if I want to. I simply click on that value and then move it over to variables. Alternatively, I could drag and drop it in the variable window and move it back if I wanted. There are always some different options that you'll have the opportunity to look through. So for instance, statistics, I'm going to get a frequency table, but I might also want to look at the mode of a variable. Once I've chosen all of the options that I'm interested in, I click OK. And then my output window comes up with all of the information that I've requested. I have simple information about the data. Here, this is telling me that there are 300 valid gender observations and 300 valid educational attainment options. There's no missing data on either of these variables. Below that, I get my frequency table for gender, and I get my frequency table for educational attainment. This is how we would interpret these tables. If you look at gender, our first column is frequency. We see that there are 196 females and 104 males. That gives us 300 total individuals in the data set. Next, we have the percent. This percent is computed as the frequency divided by the total. So 196 divided by 300 gives us 65.3%. Same thing with educational attainment. We can see that there are 2 individuals with a professional degree, and this represents 0.7% of our data set. For the university degree, there are 76 individuals, and this represents 25.3% of our data set. Let's say that rather than the one-way frequency tables that we see here, I'm interested in the two-way contingency table, or the crosstabs between gender and educational attainment. So from my data set, I'm going to go Analyze, Descriptive Statistics, Crosstabs. This is going to give us multi-way contingency tables. So in the rows, I'm going to put gender, and then in the columns, I'm going to put educational attainment. So this is going to tell me for males, for example, how many individuals have a professional degree, less than high school, and so on. And what we see is our crosstabs table. And we can see that for females, for example, 2 females have a professional degree, 26 have less than high school, 88 have high school, 53 a university degree, 27 a graduate degree. And that gives us the 196 total females, which matches what we found in our one-way frequency table. For males, we see that there are no males with a professional degree, 9 with less than high school, 46 with high school, 23 with the university degree, and 26 with the graduate degree. And that gives us the 104 males that we saw in our one-way frequency table. Now you'll notice that also across the bottom, we can look at it from the other way, that we have 2 professional degrees, which matches what we saw in our one-way professional degree table. One useful technique for visualizing frequency distributions is to put it in a graphical format. So we can go to Analyze, Descriptive Statistics, and we can go back to Frequencies. You'll notice that one of the options is Charts. I'm going to check on Charts, and we can ask for a pie chart or a bar chart, and that can be based on frequencies or percentages. I'm going to keep it as frequencies, and then I'll show you what the percentages looks like in contrast. So now we get our 2 frequency tables, but we also get a pie chart for gender and a pie chart for educational attainment. These pie charts are very easy to manipulate if you want to change colors or labels, anything like that. You simply double click on the pie chart and a new set of windows opens up, and one of them is the chart editor. So let's say that I want to change this graduate degree pie slice to, instead of being yellow, which it is now, I want to change it to be solid black. I would click on that pie slice, click on the color black, and then apply. And it changes my pie chart to a black pie wedge. Now we could also change it to different patterns if we wanted to, so that the entire pie chart could be black and white or grayscale. And then when I close it, it's saved in my output with that black pie wedge. Now I'm going to show you the alternative to do percentages. And then on style, there are some options I could do. But let's say that I want to edit this gender pie chart to also contain the percentages. So the way that I would do that is, again, double click on the chart, and what you see on the left-hand side are some options. And one of those is data label mode. If I click that, and then click on each pie chart section, it gives me the percentages, because remember, I asked for these pie charts in percentages. And then I exit data label mode, and I can continue editing my chart as I want to. I can also change what is displayed. So instead of percent gender, I could change that if I wanted to. I could change the number format to have different decimal places. I could also change the trailing characters and the leading characters and so on. And then when I close that, what you'll see is that those percentages remain on the chart. So again, to edit the charts that you create in SPSS, you simply double click on them and then you have the ability to edit. Next up, we might want to create a new variable. And the way that we're going to create this new variable is using the menus at the top. So in SPSS, you can create a new variable from a set of existing variables. In the GRIT dataset, we have 12 items from the GRIT scale, and we may want to compute the composite score by adding those 12 items together. And we can compute this new variable under the Transform tab. So transform and then compute variable. So my target variable is the name of my new variable. Here, I'm just going to call it post. The data set that I have already has a post test score in it, so I'm just going to create a variable called post. And I can do this in one of many ways. I can move one variable over at a time and then add it to the next variable and so on. I also have a set of functions on the right-hand side. If I go to simple arithmetic, I have some different options. All, I would have to scroll all the way down and find the sum function. When I move that up, it's telling me that I can add together any values that come here. So I can move all 12 variables over and create their sum. So I'll just say that the variable post is the summation of those 3 variables, and that's an easy way. And in my output window, I get confirmation that this was executed correctly. Now, when I look at my data set, you'll see that I have this new variable called post. I might want to come over and change the label in the variable view for that data set. And I'm going to say this is my other post. And instead of being nominal, I'm going to turn it into a scale variable. And now we see that it has the little ruler next to it, and it's a scale variable. Next up, I'll show you how to summarize quantitative variables. The 3 features of a quantitative variable are the center, the spread, and the shape. So values like the mean and median are used to describe the center of the data. The standard deviation, range, and interquartile range are used to describe how spread out the data is. And then skewness and kurtosis are used to describe the shape of the data. In SPSS, we can get descriptive statistics under the descriptive tabs. I'll show you how to do that. So analyze, descriptive statistics, and then descriptives. Now I'll move over my variable of interest. Here I'm moving over post-test score, and under options I can ask for a variety of different statistics. Let's say that in addition to the standard deviation, I would like the range, and I would also like the skewness and kurtosis. When I ask for descriptive statistics, I get a table that shows me that post-test score has 300 valid observations, the range is 31, the minimum value of post-test is 71, the maximum is 48, the average is 31, the standard deviation is 5, and we see some other values. So this is very helpful for us in describing different statistics about our data. We might also be interested in comparing the means for different groupings on a variable. So assume we're interested in comparing the means of the mid-test score by gender. So to do this, we would analyze and then compare means and then means. we would move mid-test to the dependent list and gender, or our grouping variable, to the independent list. And then we would click OK to run our analysis. So analyze, compare means, and then means. Here we'll move mid-test score over, and our independent variable is our grouping variable, and that's gender. Under options, we can see that we'll get mean, number of cases, standard deviation, and we could also move over other statistics if we wanted to. So we see that now we can look at the mean of the mid-test score for females and the mean of the mid-test score for males. So what we'll see is that females scored 28.49 on average on the mid-test, and males scored 29.15 on average on the mid-test. You might want to perform an independent samples t-test. To do that, we would go to Analyze, Compare Means, because remember, a t-test is comparing group means, and then we would choose Independent Samples t-test. The purpose of this workshop is not to teach you about a t-test, just to show you some of the features of SPSS. So again, I would move over mid-test score, and I'm going to compare gender. Now you can move over a grouping variable that has more than two groups. You just need to tell SPSS what those grouping variables are. So my groups, my first group would be M, and my second group would be F. And then we can see that for mid-test scores, we get those same means. And then down below, we get the results of our independent samples t-test. We get the p-value here. And again, we would say that the males and females do not differ on their mid-test score. And we know that because the p-value is greater than 0.05. Again, the purpose of this workshop is to demonstrate some very basic commands in SPSS, not to teach you about the statistical approaches. If you'd like to learn more about those, I encourage you to check out some of our ESRM courses and visit our graduate help lab on the 3rd floor of the graduate education building. Finally, I'll demonstrate how to build some graphs in SPSS. When building graphs in SPSS, you first need to think about the type of data you've collected and what information you are trying to convey. Bar or pie charts are most useful when you have categorical variables. Histograms, box plots, line graphs, scatter plots are most useful when you have quantitative variables. The Graphs menu option is your one-stop option when building graphs in SPSS. So we're going to go to Graphs, Legacy Dialogues, and then you can choose the type of graph that you want to create. So let's show you how to create a histogram. You go to Graphs, and then Legacy Dialogues, and then Histogram. Let's see a histogram for the pretest variable. Graphs, Legacy Dialogues, Histograms, and we're interested in pretest scores. And we see a histogram of the pretest score. Notice that by default, some simple descriptive statistics are included on my histogram. Let's say I want to get rid of those. I could just click on them and hit delete. Or I might want to change the size of the font of those descriptive statistics, and I can do that very easily in the chart editor. Finally, I might want to change the color of my bars to a dark red, or I could change them to have a pattern. And then when I close the chart editor, my changes are made. Well, let's say that I want to create a box plot instead. So I would go to Graphs, Legacy Dialogues, Box Plot, Simple versus Clustered. If my data are summaries for groups of cases or summaries of separate variables, I'll show you both. So I'm going to do a simple box plot where I'm going to be summarizing groups of cases. Here, the variable that I'm interested in is pretest score, and I want to look at that by gender. So that's going to go on my category axis. Now I get a box plot for females and males. And again, I can edit this by simply double clicking. Some other useful graphs are scatter plots. Again, graphs, legacy dialogues, scatter, or dot. So I can have a simple scatter plot. So I'd select simple, scatter, and then define. I need to tell SPSS which variable I want on my x-axis, and I'm going to move pre-test score, and which variable I want on my y-axis. I'll move over post-test score, and then I click OK. And I can see a scatter plot showing my pre-test score on the x-axis and my post-test score on the y-axis. And we can see that there's a general positive upward sloping trend between the data. I hope this workshop has been helpful for you for understanding some basics of SPSS. If you want more information, again, I encourage you to visit our Graduate Statistics Help Lab on the 3rd floor of the Graduate Education Building. That's room 342. Or you can visit our website, esrm.uark.edu. There, you'll find information about our Statistical Measurement Support Services, or SMSS. This is a consulting center for College of Education and Health professions, faculty, staff, and students. You can also find more information about ESRM in general on that webpage, like the courses that we teach. So again, I encourage you to visit the Graduate Statistics Lab in room 342. And thank you very much for your time and attention during these 2 workshops.